Okay, good morning, guys. So today's lesson will be finishing up the topic of organic chem, or specifically alkane. So remember the last time around we went through this substitution reaction, which is technically the main reaction in alkane. It is still the main reaction. So I merely want to add on. So in this case, this UV light thing, right? How can I limit my product? So as you can see here, technically speaking, it can keep substituting. Eventually, every H can be substituted by the Cl or the Br. That's true. But how can I control? So if I want mono substituted, meaning substitute one time, think about it. Something should be in excess. Should. So let's say our example is this reaction lah. Methane plus Cl2. So should methane or Cl2 be excess? So actually your Cl2 is limited because Cl2 is the one that is substituting. But if my Cl2 is very little, it technically can only is so little to the extent you can only substitute one time. So you can think of it this way lah. Wow, it is so little to the extent you can only substitute one time. Of course, we don't have to talk about numbers lah, but generally speaking, you can I think this kind of thought process can help you. But limited, why is limited? I think limited generally is very vague term. Limited means less, or how much less, I don't know. But let's say you take it to a little bit of an extreme. Oh, limited means very little only. So little such that I can only substitute one time. Oh, so this result in a mono substituted. You have barely enough to substitute one time. How to substitute so many times? Okay, you can think of it that way. So if on the other hand, my Cl2 is excess, means the Cl2 can keep substituting, or rather the first Cl2 can substitute, then the second Cl2 will substitute again, the third Cl2 will substitute again. So eventually you end up with something that is multi-substituted. Usually every H gets substituted lah, basically. So that is the idea of, you mean you can control it in this sense? Yes. So for this substitution, you can control it by intentionally putting one to be limited or one to be excess. Okay, cool. Yeah, so moving on. Okay, alkene. So don't worry about alkene. I will leave alkenes out. I'm not going through alkene, so don't have to worry about it. Alkene. Ignore the alkene. So they realize there's a lot of reaction, but it's a good thing that all these are not tested. So yay. This segment is tested. Cracking. What is cracking? Cracking is important. So cracking is the breaking down of long hydrocarbons to short hydrocarbon or hydrogen. So literally, not the cracking of knuckles, but more like breaking down. It's literally, you have a very long row of meat. You're taking a chopper, chop into smaller pieces, essentially. So the analogy here is like you just chop it into smaller pieces, essentially. So you might be wondering, what are you talking about? How come got chop? How come smaller pieces? Because why? The idea here is this. What cracking does is it literally just break down. It does not rearrange. It only break down. It does not rearrange. Meaning, so in this case, you have a hexane. Hexane is 1, 2, 3, 4, 5, 6. This is hexane in this equation here. When you break it down, you will get butane, which they told you, and ethene. So it is literally you taking a chopper, you chop here lah. Essentially lah, around that line lah. Yeah, so that is literally breaking. You are not rearranging it. Okay, perhaps it is still not that clear to you. Let me give you another example. So if my compound looks like this now. Same 6 carbon, but one of the carbon got a branch, or rather, it's not a straight chain. There's some extra add-on at the side. Okay, cool. So if I try and chop this down, I do cracking. Then I should be getting things like this. Plus the straight chain. Something like this. So literally in this case, I chop here lor. So you have that 2 segment. So the idea here is you are chopping it down. You are not rearranging. That means this is correct. This is correct. I cannot have. That means I cannot have the answer of this plus this. That doesn't make sense. This cannot exist because if this exists means got this protruding part. Somehow you rearrange it. Cannot. Cracking, there's no rearranging. Cracking is literally just break down. Take a chopper, chop it down. That's it. So if the original chain got some protruding part, okay lah, copy lah. Break it down. So that's the idea. So that's why I bring in the idea of is break down. Just break down, it does not rearrange. So what do you need to know? You need to know that you break down, it doesn't rearrange. And how can it be tested? Oh, very easy one. So let's say, okay, I have a C10H22 undergo cracking. And I tell you that is C6H14 plus chemical Y. Then I'll tell you, can you tell me what's the identity of Y? Then you go like, huh? What? What's happening? What? Then don't panic because this is equation. Isn't it? Equation must balance one. And in this case, it's balanced. One C10H22, give me one C6H14 and one Y. Tell me why. Kidding. Yeah, so what is Y? Balance oh. So what must Y be such that the things are balanced? The number of carbon is balanced, the number of hydrogen is balanced. So your left hand side got 10H. Your left hand side got 10H. Your right hand side so far was 6. What do you think this one the carbon would be? Such that it is balanced. Oh, left hand side 10, right hand side 6. Oh, it means 4 lah. Lol. Yeah. So it's quite logical even. H, everything should be balanced, isn't it? So in this case, my H is 22 on the left hand side. My right hand side is 14. Mathematics tells me that my H would be 22 minus 14, which is 8. Oh, so a possible identity would be butene, no? Whatever lah. So that's it. So this is what you need to know. They will give you some pattern, they ask you to go and figure out. Second version they can tell you is they show you the structures, you don't go and rearrange, you chop it down. Literally looks the same structure wise. Next thing they can ask you, oh, what is the reagent condition? So reagent is very simple. Reagent means reactant. It is just the hydrocarbon lor. Your oil or crude oil to break down lor. The conditions on the other hand is a different thing. So this is the conditions you have to take note. Again, for me context, you think you only learn like 3 reactions, right? So cracking of long hydrocarbon, substitution of alkane, everything can burn, combustion. Confirm got test one of these or two of these one what. So the very peculiar thing here is two things peculiar here. First thing peculiar is normally catalyst is one enough already. This one very special eh. 2 catalysts. Wow. It's very special. You need 2 catalysts. Second thing about the catalyst is interesting that remember normally catalyst should have a transition metal. In fact, that's one of the key properties of a transition metal. But in this case, do we have transition metal here? No. So this particular reaction very interesting, because it's the first time you see that include 2 catalysts together. And the catalysts actually don't have any transition metal, but yet they can be catalysts. Very interesting. Temperature wise, 600 degrees is a need to know one. This one has a fixed temperature, which is very hot obviously. So it's easily just alkane, break down to form alkene, or hydrogen gases. Just make sure that it balances the equation. Yeah, that's it. That's cracking. This is the setup lah. So technically speaking, I can do this in the lab in some sense, I guess. But not really practical exam lah, don't worry about it. So what is the good thing about it? It produces short chain. Short chain? What is short chain? Think of it this way. Remember your crude oil? You can separate the crude oil into 7 components, and the last one is bitumen. Bitumen is very big. What's the use of bitumen? Pave the road. Lol. Not much value. But the one on top is actually petroleum gas things that are very useful. They burn very easily. So generally short chain alkenes, they are more valuable. They have more uses. So cracking helps me to overcome that supply demand issue . I want my short chain, I don't want my long chain. So by doing cracking, I can change my long chain into short chain. So I got more short chain. Means good more uses. So that is a good thing about cracking. It also produces hydrogen. So in case you don't remember your Haber process? N2 plus H2 give you reversible 2NH3. This is the main so this cracking is the main source of providing hydrogen for this Haber process. And Haber process in the world is very useful. It's very important. Without Haber process, you probably don't have fertilizer. No fertilizer, no crops. No crops, everybody starve and die. So things that involve ammonium is always gonna be high value in the world. For like the current ongoing Ukraine-Russia war, it is affecting the crop prices. How? 2 ways. One way, the oil price is going up, and when oil go up, everything need electricity and most likely electricity come from oil, burn oil, so everything increase in cost. Second thing, Russia and Ukraine, they are the world top producer of wheat, which is used to make bread and a lot of things, food. And also Russia is a huge, if not the biggest, world supplier of fertilizer. Now got so much sanctions against them, means it can be there's a shortfall . So that shows you ammonia or ammonium related substances are very, very, very in demand, which means hydrogen is in demand, which means cracking is important. Yeah. And then, as I said, it changed the larger mass one to smaller mass, which is more useful . Yeah. So it's, in a sense, it's converting your not so valuable things into more valuable things. Or a more extreme example is like converting your trash into money, essentially, in some sense . Okay, maybe not trash, but you get the idea here. Okay, comparing alkane, this is called a distinguishing test. Saturated, unsaturated, this is not tested . I won't burden you further. I know you have a lot to study for many subjects. So actually, based on this, it's sufficient. Yeah, that's the main thing I have for you for alkane intro to organic chem. Everything I covered so far is tested, and that's about it. We've finished the syllabus so far, and You might be wondering, wow, so fast ah? Then our lessons you got 40 minutes there about do what? Very simple. Why not take the time to revise, then you do your practical paper, then you hand it on Monday. Good idea, right? Alright. Go ahead and do your work. All the best. Any questions, do feel free to ask me over Teams or ask me in class. You know that you can I'm usually available. Alright.